Okay, we're going to go ahead and get started on the next portion of our video for the linked list series, and that is with the two functions add at and remove at. As part of your assignment, you will have to complete the remove at, and I'll give you kind of a little bit of a hint on where to go to complete that portion. We're going to set up the linked list to contain these items, 1, 2, and then 4. And what we want to do is we want to add at a specific point in the list, in between two nodes somewhere. So essentially what we have right now is, well, nothing yet, because I haven't actually added anything to the linked list that we were working on from the last video. So we're going to do an add to make it look the linked list to contain these items. We're going to do some additions to the list here. We want to probably do an add rear of 1, and we'll continue with add rear for the remainder of the nodes. And we'll have 1, 2, and 4. Okay, so the address on that, or the addressing of that, I've already put in, but remember, addressing is, I'm just making these up because these come from the compiler. So the way it kind of looks, I'll draw some links in here for you. Once I get the pin program going. Okay, so head is pointing to the first one. That was from our first add rear. Then our next add rear, we add the next node, which is pointing to 200. And then I purposely left a space here because we're going to be filling a node in there, but currently it's not there. So this node points to the 4. So the one that contains 2 points to the node that contains 4. And we're going to have a node that we're going to add here with the add at function that we're going to develop. And we're pretty much close to getting that done with everything we built so far. So let's just verify that what I've got here is working. And what we'll do is, if I remember right, we have a text box or a list box that we're printing to. So I'm going to have to pass the print. I'm going to have to pass list box 1 just to see. And we should get 1, 2, and 4 as an output. Okay, so everything's working right. What we want to do is we want to eventually have a node that's going to go right in between here, and let's say it's going to have the value 3. So that node, how is it that we're going to make that connection in between? And how does that work? So I'm going to go ahead and make some room for it in the diagram, and then we can kind of write the code as we go and diagram it out. I'm just going to put this guy right here for now, and then erase all these lines. I'll make the lines here pretty soon. Let's go ahead and get started with the code. The add at function, of course, is going to be very close to what we've already done, but it's going to be a little bit different because we're actually going to have to walk. We're going to have to start a current pointer at the beginning of where head points to, pointing to the first one, and walk for an index. And the index is going to be an argument that the user of the linked list passes. So it's going to be very close to our add front, add rear, minus a few changes. So we can begin with just copying and pasting the add front and renaming it. And that can become now add at. So here's kind of where this differs. The add at function is where you're going to be passing it the item that you're going to want to store in the node, and where in the list you want to inject it in between two nodes. So that would be referred to as an index. And that's an integral. And basically, if we pass it an index of 0, that means we want to add to the front. If we pass it an index greater than the count or the size of the current list, which is 3, that means we want to add at the rear. But if we pass it an index in between, like say an index 1, that means we want to be in between the first and the second one. An index of 2 means that we want to be between the second and the third one, and so forth. And of course, you can build this however you want, and the index could be 0 for being in here, 1 for here. It's all about how you build your loop and to walk the list and make those connections. So the way this would behave is we would run it and call the function add at, pass it the value that we want and the index we want. So the way I'm going to do it is I'm going to have 0 being the add front, 1 being the add between the first and the second, 2 index between the third and the fourth, or the second and the third, excuse me. And then if anything's greater than the count or the size, or equal to the count or the size of the linked list and the nodes that it has, then that's going to be an add rear. So if I wanted to inject a node in between here, 0's here, I'm going to go ahead and mark that a little bit. This will be 0, 1, and then 2 would be in here. So I'm going to go ahead and pass in an index of 2, and then we're going to write the code to make it work the way we want, or the way I want. Okay, so pass in the index, and now we're also building the code to be able to handle for any index. So that means that we got to look at this variable, and we only need to look at it if we already have current nodes. So the first thing you do when you do an add at is, hey, do I even have a node in the list box? And if the answer is false or true, you got to make a decision. If you already have a node in there, then of course you're going to be making some links. If you don't, then hey, the first one is your head. So we only need to look at the different behaviors or have different index choices in the else statement. So what we're going to do is we're going to say if index equals 0. That means I just want to do an add front. So I'm just going to call the add front we already have. It's already built, and we can just call it and pass it in the storage variable that we want to store. Else, if index is greater than or equal to count, that means that we want to do an add rear. So count in this case would be 3. So 0, 1, 2, 3. So yeah, it is greater than or equal to. Add rear, pass it in the storage. Now here's a little bug that usually happens with this count plus plus can only happen in this else statement or in the beginning. So we've got to do a little bit of a change with this count plus plus. We've got to take that and move it so that it only happens here or here, because we already have a count plus plus in this function and in this function. And since our linking code is going to be totally different, I'm going to go ahead and take that out. Oops, I hit some keys I shouldn't have done, so I'm going to have to hit stop here. Let's go back to where we were at. Save all. Make sure I didn't miss anything. Oh, okay, we're good. So that count plus plus only happens after we've made the link and we've actually created the new node. So essentially, the new node is created and ready to go. And what we can do is then start on our linking. Let's go ahead and draw some things out on the diagram here so we kind of know what's going on. This is the new node that contains 3, and it's called end node. So we have a reference type to it. and that reference type is called endNode, which is our new node. And let's say that it is at address 350. So endNode is 350. It has its own unique address, whatever the compiler gives us. So now endNode is sent to point to that number 3, or the node that contains number 3. And its next, it defaults to pointing to nothing. But we want it to essentially point here, eventually the next portion. So currently we have these connections. We have head pointing to our first node, its next pointing to the next one, and then we have this guy pointing over here. And of course our new node points to the new node that we're going to be injecting. So what we want to happen is we want to have this next pointing here and the next here pointing down to here. So we want this reference to have the address 350 in it, and this reference to have the address 10 in it. And that will then make the connections between. So let's go ahead and write the code to do that. And the first link we're going to want to make is, since we don't want to lose this guy, because as soon as we get to this point, if we make this link before we save the link to this guy, then we've got a problem. But at the same time, we need to get some kind of pointer to pointing to this link, which means we need to walk the list with some kind of current pointer, and we want to do it within a loop. So that is what we're going to create. We're going to create a current pointer, and we're going to set it equal to head so that we can use that to walk. So we can get something that actually points to that node of interest that's right before the one that we want to inject in between the two nodes. So that current node is going to be starting out as equal to head, so it's going to start out containing address 100, and we're going to have it pointing to the very beginning here. So it's going to point there. So let's write the code for that, and it's going to look like this. Node current equals head. And we've just taken care of this step right here. So now what we want to do is we want to build some code that will walk current down the nodes to get to the one right before the node that we're going to inject in between the two. But we also got to build this so that it will work for any amount or quantity of nodes that are in the list. So in other words, we don't want to make it just for a special case that I'm diagramming right here. It's got to work for every case. So we're going to have to do some kind of while loop. And actually, you know, since we do have a count variable, we can use the count variable in our loop. So we can do, well, would the index variable work also? Index would be 0, 1, 2. And the first time this runs, current's going to be pointing to the head, and then we need to have it point to the next one. I think we can do this. I think we can say for int I equals 0, I is less than index I plus plus. Now we might have a fence post. I might have to do index minus 1, and of course we'll just test it and see. So what we're going to do is we're just going to walk. We're going to walk the current node to current's next. So let's kind of map this out. Let's say that I'm passing it an index of 2 from main here. So what's going to end up happening is this loop is going to run twice. So that means current is going to be equal to current next once. It's going to point over here. Then the second time it runs, it's going to point to the 4. So that is a fence post. So we're going to need to do -1 because we want it to go to the one right before the index. So essentially, the first time this runs, current points to here after this loop runs once. And in this case, if we're passing index of 2, 2 minus 1 is 1, so this only runs once whatsoever. But if we are working with higher numbers here as far as what index we want, it is also going to still work. So I think this is good. Once we have current here, we can then start making some links, but we don't want to make this link yet because then we lose the reference to the number 4. So we want to make this link first. So what I'm going to do is after this loop runs, I know current is pointing in the right spot. So I'm going to do, let's see, we have end node that's pointing here. So I can just say end nodes next equals currents next. Current next holds the address 10 right here. So end node, its next equals currents next. And what that does is we go to currents next, that's address 10, and we go to end node, and end node's next, it's currently pointing nowhere, and we want to make it point to this guy, which is at address 10. So that's what happens because currents next holds address 10. So now this link is made. It's done. And this link is gone. That one's gone. Okay, so now we've kept the reference here. We don't have this reference yet. So what we do in the next line of code to make this one happen is we say current next equals end node. Because end node holds the address 350. Currents next used to hold or still holds this guy, address 4. So now we want it to be holding 350. And then now this connection is fully made and this one is no longer there. And I think we've now injected a node in between, and what ends up happening is when this function gets done running, since current is a local variable, it is deleted. End node is a local variable on the stack, it is removed, and therefore all those little reference data types that we used to make the connection are now gone, and this is what we're left with. So when I do a print, right now from what I can tell, the add function is complete. It is done. When I do a print, we should get 1, 2, 3, 4. Okay, so let's go ahead and try this out, and we'll go back here, and we're going to actually try some more out and kind of really test it and see if it works. Okay, we got 1, 2, 3, 4. So let's go ahead and do an add of 0. In fact, let's trace some of these and just kind of look at what they're doing. And let's do an add what's the count? 1, 2, 3, 4, 5, 6. An add of 6. Okay. And then let's do a add of 4. Or 4 at index 4. That works. Okay. So I'm going to set a breakpoint here. That one we already tested. Let's set it right here. We're going to go to index 0. So what should be happening is an add front. I'm going to step into and step over. We get into our else statement. And sure enough, our add front works. and we're done. And then we go on to the next one. This one should, since it's higher than count, and the count is 1, 2, 3, 4, 5, 6. Actually, it's 5. It should do an add rear. So I'm going to do step into, step over, and there it is, add rear. Okay, and it's done. So now we've got the index 4 going at the index 4. So the index of 1, 2, 3, 4. Oh, these are like, this is add front and this is add rear. So I have no clue what it's going to do, but we'll find out. I'm sure we can map it out and make sure it works right as soon as we're done printing it. So hit play. So currently we have 4 in the 4th spot. 1, 2, 3, 4. Okay, that worked. And of course we can, make sure that it's behaving appropriately by using some interesting numbers, such as -99. So we'll check on that. 1, 2, 3, 4. Okay. Looks like it's all working as intended. Now here is your assignment for the whole linked list, portion of chapter 19, I believe, is for you to go ahead and complete the remove at function. Now, what we can do is we can take the add at function as kind of a copy and use it and kind of inverse everything that's in there. So I'm going to paste that, and then I'm going to call this, I'm going to say remove at. Now, since we're removing, we don't need to send it anything for storing. We're just going to send it an index of what we want removed. And then we're going to have an error correction. Basically, we can say here, we don't want to do anything as long as, we only want to do something as long as head is not null. So that means if we're trying to remove an empty list, don't do anything. So if head, well, actually, let's just do head does not equal null. That works. So this is going to be, if index is 0, we're just going to replace that with remove front. Just kind of an inverse of our add. And then this is going to be remove rear. And we do need to walk the list. So you're going to have to walk the list to get to the node that you want to delete based on the index. So it could be that you will keep this same loop to make sure that you get your task done. And then once you get to the node that is right before the one you want to delete, then what you're going to do is you're going to connect the next pointer or reference type to the next. I want you to think about, the poor man's linked list and how that .next behavior worked for that one line of code that you need right here. And I do believe that you can probably get it done without having to mess with this at all, and just write that one line of code right there to complete your assignment. Now, the next video for linked lists, what we're going to be doing is we're going to be converting all of this into a doubly linked circular list, which means we're going to introduce the idea of a previous pointer. And what I'm going to do is I'm going to modify the whole list to include that previous pointer, which means I'm going to have to break out some bigger stencils here for our node, which is fine. I'll develop one with 2 reference types in it. It's going to have a next and a previous inside, so we're going to have some interesting artwork when we get into that. And I'm going to go ahead and when we do that video, or when I do that video, I'm going to leave this one unfinished so that it's, you guys can use that as a good challenge for yourself for your assignment. Okay, that's it. Thank you.